Welcome back. In the last tutorial, we created a 3D groundwater model by adding a second layer. However, the model still doesn't calculate 3D flow, meaning water can't move between layers. To allow 3D flow, we'll need to add Spatially Variable Area Source sinks, or SVAS points, to our model. Of course, you must be wondering, what is SVAS? To put it simply, SVAS is a set of equations which calculates the vertical flow of water in Anaqsim. Without it, the model behaves like two independent layers with no interaction. We are going to introduce SVAS from a purely application standpoint in this video. But if you'd like to dive deeper into how SVAS works, we also have a lecture video by Dr. Fitz. That video is available in our lecture series. Check it out if you're interested in learning more about the theory behind SVAS. Now let's simulate what happens before and after we add SVAS points. If you don't already have your model open, let's load it up now. First, click File in the top menu bar. Then select Open and choose the model file you created in the last tutorial. Click Open and the model will load into Anaqsim. Now that we have our model open, let's see what happens when we add a well to the lower aquifer domain to see if it affects the upper layer. Go to Model Input in the top menu bar. Select Wells from the drop-down menu. In the next menu, choose Head Specified. In the input table, set XY coordinates to 0, 0. Then select the lower aquifer as the domain. Finally, set the specified head to 40 meters. And I'll just recall here that we set up this model assuming the units of meters and days. So, we have just set our pumping well such that it will draw down water until it reaches 40 meters in elevation. This is 5 meters above the bottom of our aquifer, which we previously set as 35 meters in elevation. Now click File and then Save. Now that we've added the well, let's solve the model and check out the results. First, click Solve in the top menu bar. Then go to Make Plot and choose All Selected Features. Choose Level Time. From the drop-down menu, select Layer 2, which is our lower aquifer domain. You'll see a typical cone of depression around the well. Now, go back to Make Plot, and this time select Layer 1, which is where we have the aquifer and channel domains. You'll notice no effect from the well in Layer 1, because 3D flow isn't enabled yet. Now, let's enable 3D flow by adding SVAS points to our aquifer and channel domains. Go to Model Input in the top menu bar. Click on Area Source Sink from the drop-down menu. You will see several options. Select Spatially Variable Domain to apply the SVAS point evenly across an entire domain area. In the input table, first click on Domain, and you will see the names of all 3 domains that we created. Choose Aquifer, or whatever name you gave to the upper aquifer layer that you created. Next, go far right of the table and set the node spacing to 100 meters. Now click Enter, and in the field below, repeat these steps for the channel domain. You can leave all of the other input fields with their default values for this example. I'll just note that this input field is where you can include recharge and evaporation for more complex models. Now click File and Save. I need to pause here for a moment to say that this 100-meter spacing is coarse for this model. But it allows the model to converge quickly so we can see the effects of 3D flow. In the next video, we'll go over how to refine SVAS spacing for efficient modeling. Because of the coarse resolution, you'll notice that the output looks a bit blocky. Before we solve this model, let's add some additional SVAS points immediately around our well where the vertical flow is greatest. Anaqsim has SVAS point generator specifically intended for this. Go back to Model Input in the top menu bar. Click Area Source Sink from the drop-down menu again. This time select Spatially Variable Well Basis Points. In the input table, click the blank space under Max Node Spacing and enter 30, which is the SVAS spacing distance in meters. Then under Points per Circle, click and choose the value 6 from the drop-down menu. Finally, under Well Labels, click Select. You will see all of the recorded wells, but since we only added one well, you will only have one option here. Select it. Now click File and Save. Before we leave this setting, I want to point out that the SVAS points you set on your wells will move with your wells. So, you only need to assign these SVAS around your well once. This is handy when you need to test different locations for a well in your model. Anaqsim can display the SVAS points for you. Let's have a look. Go to Plot Input, then choose What to Plot from the drop-down menu. Within the Input table, go to Elements, and from that drop-down menu, select Elements with Details Control Points. Now click File and Save. Then plot the output again by going to Make Plot and choose Model Elements Only. Click to overwrite the last model solve, and then we can see just the elements that we created. You will see there are cross marks within the domain. These are the SVAS points that we just added. So now that we've added some SVAS points, let's solve the model again and check out the difference. As always, click Solve in the top menu bar. Then go to Make Plot, then choose All Selected Features, choose Level Time. This time, let's start by selecting Layer 1. Now you'll see a cone of depression in the upper layer, which means 3D flow is working. Up to this point, we have created a simple 3D model with multiple layers and domains. We then simulated 3D flow by assigning SVAS points. The model we created allowed us to play with the software. But the model we created is rather clunky, with low resolution and too many equations for such a simple model. Sure, the model works, and you could improve the output by adding more SVAS points, but it's ugly and works through brute force. So, our next step is to add some efficiency and elegance to your models. To do this, we'll have a proper look at applying the SVAS to your models, and soon you'll be creating even more complex models with higher resolution and fewer equations like a pro. Thanks for watching. See you in the next one.